So now we're going to look at an algebraic concept, composition of functions, and we want to consider the composition of a trig function with an inverse trig function. So really there's nothing new in this video other than more examples with trig and inverse trig functions. So let's look at an example here. Determine the cosine inverse of sine of 5 pi over 3. So composition is where you have one function input to another function. So here we have a sine function as the input to a cosine inverse function. And the way you work composition functions is you work on the input first. So you start on the inside. So the first thing we need to know is the sine of 5 pi over 3. So I'll come over here to the side and I need to locate 5 pi over 3. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3 is down here with a 60-degree reference angle, okay? So that means I want the sine, which will be the vertical side of this 30, 60, 90, so that would be square root of 3 over 2, since it's opposite the 60-degree angle. And since it's down, it's negative square root of 3 over 2. So the sine of 5 pi over 3 can be replaced with negative square root of 3 over 2. But I need to know the cosine inverse of that. Okay, so now we've got a totally new problem. I need to know the cosine inverse of negative square root of 3 over 2. So now I'm looking for, since this is a cosine inverse, I'm looking for a reference triangle whose horizontal side is negative square root of 3 over 2. So if I consider that, a negative horizontal side means that I'm to the left, okay? And it's negative square root of 3 over 2. So that's the long side of a 30, 60, 90. So that it could be right here, and my vertical side would go up like this, and I could be in quadrant 2. Or if I consider it down here, my vertical side would go down, and my reference triangle would be in quadrant 3, okay? In either case, the horizontal side is negative square root of 3 over 2. Now both of these have a reference angle of 30 degrees, okay? So if I zoom in here, this angle is 30 degrees, or pi over 6 for both of them, okay? Should recognize that from your 30, 60, 90. Here, let me erase this negative square root of 3 over 2. That's the horizontal side here, but now we can focus more on the angles, okay? So now I've got to figure out which angle is the cosine inverse function gonna give me as the output. Well, I have to decide, do I want the angle from 0 to this terminal side or the angle from 0 to this terminal side? Since they have equal rotation, I want to choose the positive angle because they both have equal rotation. This guy's a negative rotation, so I want to choose the one up here on the top. Well, if this is pi over 6, then the blue angle from 0 would be pi over 6 away from pi, because right here is pi. So if I start at pi and I back up pi over 6, I get 5 pi over 6. So the cosine inverse of negative square root of 3 over 2 is the angle 5 pi over 6. Okay, so we did a couple things there. We had to find the sine of 5 pi over 3. We got it. And then we had to do the cosine inverse of that ratio, and we got it. All right, let's try another example. Determine tangent of sine inverse of square root of 2 over 2. So now the input is an inverse trig function, so we've got to do some work with that. All right. So the sine inverse of square root of 2 over 2 is an angle whose vertical side equals square root of 2 over 2. So if I got a positive vertical side, I could be in the first quadrant or the second quadrant, and the vertical side should be positive square root of 2 over 2 in each case, with a hypotenuse of 1. These are 45, 45, 90s, so 45-degree reference angles. And I've got to measure my angle to this terminal side from 0, or from 0 to this terminal side. Well, in this case, the first one has the least amount of rotation, so we're going to go with him. And since that's a 45-degree rotation, it's the same thing as pi over 4. So the sine inverse of square root of 2 is pi over 4. That's the angle it outputs. But I still need to take the tangent of that angle. So now I need the tangent of pi over 4. Well, pi over 4, if I clean this up, pi over 4, tangent's going to be vertical over horizontal. The vertical side is square root of 2 over 2. The horizontal side is also square root of 2 over 2. So the tangent's going to be vertical divided by horizontal, which will be 1. So the answer to this question is 1. All right. Let's do another example. Determine the cosine of tan inverse of 1/4. Okay. So we start with tan inverse of 1/4. Now, this one's tricky because tan inverse of 1/4 is not going to give us a 30, 60, 90 or 45, 45, 90. So we're going to take a different path here. Whenever the inverse trig function is not something you're familiar with working with, what we do a lot of times, since we know that it outputs an angle, we just call it theta. Okay, so what is theta? Theta is tan inverse of 1/4. All right? And I want to know the cosine of that unknown angle. But what I can do now is I can learn about theta based on this information. So if theta is the tan inverse of 4, then I can look at the inverse statement of that. So in other words, the tangent of theta has to be 1/4, right? Make theta the input to the tangent function, which would make 1/4 the output of the tangent function. And so tangent of theta being 1/4 means tangent's positive in the first and third quadrants. Tangent is vertical over horizontal, so my vertical side would be 1. My horizontal side would be 4. Okay? Now in quadrant 1, they're both positive. 4 goes to the right and 1 goes up. But in quadrant 3, they're both negative because 4 goes left and 1 goes down. So I've got to figure out which of these two angles is theta. So this angle involves that much rotation, whereas the bottom angle requires that much. So we're going to choose this to be angle theta, whatever that may be. Okay? Now I've got the reference triangle for theta. I can come back to the original question and determine the cosine of that angle theta. So if I blow this triangle up, all I'm going to do is recopy this triangle right here. Of course, it's not drawn to scale. And I need to know the cosine of theta, which is the horizontal side over the hypotenuse, because now our hypotenuse is not 1. The Pythagorean theorem tells us it's the square root of 16 plus 1, which is the square root of 17. So the cosine of theta is going to be the adjacent over the hypotenuse, or horizontal over the hypotenuse, which is 4 over the square root of 17. Or if you rationalize the denominator, that's 4 times the square root of 17 over 17. And there we go. So that one's a little trickier, but the key that you want to pick up from this is when you don't know the output of an inverse trig function, just call it theta and work with that. And then inverse that statement to be the original trig function. So instead of tan inverse, inverse it so it turns back into tangent. Okay? I hope this makes sense, and good luck practicing.